Hey guys, today we're going to go through a lesson, and then after the lesson you'll have an individual assignment. So please make sure you're taking notes and following along. If you need to pause, feel free to pause and jot down anything you need to jot down. Okay, so today's standard is MAFS.6.NS.3.6C, and it states find and position integers and other rational numbers on a horizontal or vertical number line diagram. Find and position pairs of integers and other rational numbers on a coordinate plane. So just a reminder, when we're talking about a horizontal number line, that's a number line that's going from left to right or right to left, and as any number line, it typically has a 0, and anything to the right of the 0 are going to be positive numbers. So we have 1, 2, 3, 4, 5. Obviously, it could be any increments of numbers, but on this number line, it's 1, 2, 3, 4, 5. And to the left of 0 are negative numbers. As you're looking at this number line, you'll realize that anything to the right of 0, as you're moving to the right, your numbers are increasing, or the value of the numbers are increasing. And when you're dealing with numbers to the left of the 0, your numbers are actually getting smaller. So when we think of -5, -5 is actually smaller than -1. -4 is smaller than -3. Another way to think of this when you're dealing with the left side of 0 is that the number that's closest to 0 is actually the bigger number. Okay, and that's only for negative numbers. But when you're dealing with positive numbers, the number that's furthest away from 0 is actually the biggest number. Okay, now when we're looking at vertical number lines, once again you have your 0. And in this case, the number line is going up and down. So this was left to right, but this is going to be up and down. And anything above 0 is going to be your positive numbers. And then anything below 0 are your negative numbers. So once again, when we're looking above 0, the further you get away from the 0, when we're dealing with positive numbers, the bigger the number. And then when we're dealing with negative numbers, the further you get away from 0 or go below 0 is going to be a smaller number. Okay, so looking at this, -2 is actually bigger than -1. Okay, that's just a reminder. But when we're looking at, when we're talking about a coordinate plane, if you look at a horizontal number line and a vertical number line, a coordinate plane essentially is just a vertical and horizontal number line positioned together. So let me just show you an example. So we have, let me get a different color. Okay, so here's our horizontal number line. I know it's not a great drawing, but bear with me. All right, and here's our 0. And if we were to take a vertical number line and just shift it over and place it right through that 0, we now have our coordinate plane. And that's what we're going to get into now. You should be familiar with a coordinate plane, but just in case we need a refresher, we're going to do a refresher really quickly and then move into today's standard. Okay, so when we're looking at a horizontal or vertical number line, questions you might have seen in the past would be questions as, what is the opposite of -5? Granted, at this point, you can think of the opposite of -5 is +5. But just if we wanted a visual or to place that on a horizontal number line, you will look at -5, and let's say we want to go ahead and plot -5 on this horizontal number line. We know it's going to be to the left because here's my 0, and anything to the left will be negative. So just keep in mind we're looking at negative. Now, when we're talking about opposites, yes, we know that the opposite is 5, but just keep in mind that when we're referring to opposites, opposites would have the same distance from 0. So here is my 0, and when I'm thinking about -5, if I was to count the distance, it is 1, 2, 3, 4, 5 units from to the left of 0. So that would have to mean that +5 would have to be in the opposite direction, and then 5 units to the right of 0. So You would always start at 0. That is your center point. And then 1, 2, 3, 4, 5. So just keep that in mind if they were ever to ask you why it's positive 5. It's essentially the same distance from 0. And you can do that with a vertical number line as well. Let me just make one really quickly. If I was asking you, what is the opposite of positive 3? You can go ahead and plot your 3. Or even if they were asking you to plot positive 3 and its opposite, obviously it would be 3. You know it's negative 3. And another way to explain it, once again, is just, here's my 0. The distance from 0 to positive 3 is 1, 2, 3 units. So to get the distance of the opposite number, you would have to go in the opposite direction. So always start at 0 and then 1, 2, 3 units in the opposite direction, which in this case is going below the 0. Okay? Okay, moving into a coordinate plane. Let's just kind of look at this plane and make sure we're able to identify the different quadrants. So looking at this, I just want to point out, here is my vertical number line and here is my horizontal number line. But when we're referring to a coordinate plane, my vertical number line is my y-axis and my horizontal number line is my x-axis. So when they intersect, that intersecting point is always going to be your origin. So my origin is the exact point in which the x-axis and the y-axis intersect, just another word for cross. Okay, and so when they cross, they make different quadrants. And at this point, they might ask you, what are these quadrants? And typically, students get them confused because they want to read them from left to right. But when we're referring to quadrants, go ahead and jot this down. Quadrant 1 would be here. So any point you plot in this area, in the top right-hand corner, would be considered a point in quadrant 1 or an ordered pair in quadrant 1. Quadrant 2 is the top left corner. Quadrant 3, and then quadrant 4. So the way I remembered it when I was your age is I always started on the top right-hand corner, and then I moved to the left, down, and then over. Okay, so 1, 2, 3, 4. Always start on the top right-hand corner. Okay, graphing points on a coordinate plane, just a refresher. Remember, it's always x, comma, y. So no matter what your ordered pair is, it's never going to change. It's going to be your x is first and your y is second. So you're always going to start at the origin. And let's say I give you a point like 3, comma, negative 4. Because your x is always going to be first, that means you're always going to move on your x-axis first. So my x-axis, once again, is that horizontal line. Before you go up or down, so before we are able to move in any direction up or down, we have to move left or right first. So here's my origin. The only reason I would be moving to the left is because my x is a negative number, because anything to the left of 0 is a negative number. So if I have an x that's a positive number, keep in mind you are moving to the right first. All right, remember you have to move left or right first before going up or down. So let's look at this. My x is a positive 3, so I always start at 0, the origin, and move 3 units to the right. So all I'm doing is going over to the 3. 1, 2, 3. I'm going to stop here and then just look at what is my y. My y is a negative 4. So the same thing, I'm going to go ahead and go down to negative 4, but 1, 2, 3, 4, and then my point is going to be here. The same thing goes for the vertical number line. The only reason I would move down is because my y is a negative number. If my y was a positive number, I would have to move up. Okay, so just keep that in mind. Don't get confused when you're looking at a coordinate plane. Think of it as this is a horizontal number line, this is a vertical number line, and you know how to deal with those already, okay? And then when you put them together, always move left or right first and then up or down. Let's just try another one, and before you watch it, maybe you want to pause it and just make sure you're able to plot these correctly. So let's do -5. Let's do +6. So if you want to pause it here and just try, just to make sure we're on the same page. Okay, so I'm going to let's use purple. All right, so once again, always start at the origin, 0, 0. And looking at this, I like to just identify my X and Y. It helps me. If you want to do it, I would always recommend just identify your X and Y first. So in this case, my X is a negative. So off the top of my head, I know I'm going to be moving to the left first because there are no negative numbers on the right. So we're going to move to the left. We're going to go to -5. Now we're going to look at the Y. The Y is a +6, and we can only move up to go to positive numbers. So we're going to go up to the 6, and then there is our point. Please make sure this is like a roadmap, and you're not stopping until you use every direction that's given to you actually get. So your ordered pair is like your directions, and then when you get there, that's where you put the point. Don't put the point when you only get halfway there and you only have your X. Make sure you get all the way through to your Y and then put your point there. Graph your point. Okay, let's move on. Okay, just a quick practice question. What coordinate best represents the location of point K on the coordinate plane below? So if they give you a point on the plane and they don't give you an ordered pair, it just means you have to create your ordered pair. And so same concept, you still want to always start at the origin, which is my 0, 0. And I'm basically trying to drive to my location this time and just get there. So when I'm looking at this, I know there would be no reason I'm moving to the right because my K is right here. So if I move this direction, there's no way I'm going to get to the K. So when you look at this, you know you're going to start at 0 and move to the left. And you want to stop right on top of the point before you move any further down. So this looks like, if I'm looking at this correctly, this looks like my X would be a -7 because it's in between -6 and -8. Okay, and so halfway in between those two numbers would be a -7. So now I've moved on my X-axis, I went to the left, and now I'm going to go down to get to my actual point. And so when I look at this K and I go over to see what number it's on, it is on -4. So that means my Y is going to be -4. Until you get comfortable, just practice it. Take your ordered pair and actually go make sure it reads correctly. Because let's say you put this in the wrong order and you got -4, -7. Okay, if you just go back and take a second to make sure if your ordered pair was correct, you would see if you went -4, -7, it would be somewhere here. And so just keep that in mind. It takes a second to check your ordered pair to make sure you put it in the right order. It's an easy point, so take that extra second. Okay, which ordered pair best describes the point plotted in quadrant 2 on the coordinate plane shown? So if you're in class, I want you to just pause this video and let's raise our hand. Let's call this point A, point B, point C, and then point D. Okay, for those that are online, test yourself and see if you get this correct. Okay, so if you chose point B, you got the correct answer because, as I said earlier, you always start, quadrant 1 is always going to be on your top right-hand corner, so keep that in mind. This is quadrant 1. So if we're moving basically counterclockwise, so we start here, we're moving counterclockwise, this would be quadrant 2, quadrant 3, and then quadrant 4. And I'm using Roman numerals, but if you want to use 1, 2, 3, and 4. Okay, so point B would be in quadrant 2. This is a form of question that you would see that they're not going to tell you. They might not even ask you for the ordered pair. They're just asking, making sure you know the different quadrants. So take some time to just practice that, review that in your head, because that's another easy point, knowing your quadrants. Okay, so this question here, you're going to have a very similar question. It is not the same exact question, so please don't say this is the same exact question on your independent work. I changed the numbers around. But you will have a very similar question to this, so please make sure you're paying attention so we can identify how to move on the coordinate plane. All right, so it says the image below represents the town map of Raleigh-Ville. Complete the following table. So let me give a little bit more background. Let's say the mayor is building these new locations, a hair salon, a dog park, and a movie theater. And they tell you that the locations are these distances from what's already there, the current landmarks. So the home, the school, the library, the skate park. And you're trying to find the new ordered pair once you move or once you go to the new location using the identification that's been given to you or the movement that's been given to you. So when I'm looking at this, let me get a different color. Let's start with the hair salon. So we're trying to figure out where the hair salon would be at. All right, so it says 8 units west from home. So immediately they're using west, south, and east. So they're not using to the left, to the right, up, or down. So for me, I'm going to have to pull out some previous knowledge and draw my compass. Okay, back when I was growing up, we used something as never eat shredded wheat. I don't know what you guys use now, but that's still what I use. So this is my north, my east, my south, and my west. And then looking at this, this actually looks like a coordinate plane. So if this was my 0, north would be going up on the vertical axis, south would be going down, east would be going to the right on the horizontal axis, and then west would be going to the left. So this essentially is my y-axis and my x-axis. All right, so let's look at this. So it says 8 units west from home. So let's just start where we're at first. We are here. This is our home. And we're going 8 units west. So west is to the left. The reason I know it's to the left is because I'm going to always look at my 0, and then to go west, you have to go to the left, okay? So, but we're not going to, a common mistake is that you want to go down here and then go 8 units to the left. No, it's saying 8 units from home. So we're going to go 8 units west from the home. So I use something called bunny hops. You can use whatever you want to use to help you understand it. I start at the starting point and I bunny hop, and that's going to be 8 units west. So here we go. So we're going to go 1, 2 bunny hops, 3, 4 bunny hops, 5 bunny hops, 6 bunny hops, 7 bunny hops, 8. And I land right here. So my first step is actually knowing which direction to move. Once I get that, I now have to go ahead and put my new ordered pair. So that's a whole nother, concept we have to make sure we grasp as well. So here is my new points. So to get the ordered pair, once again, start at 0, 0, the origin. And we see that the ordered pair is over here, so the only way to get there is to move to the left first. So I'm going to move to the left to get right under the ordered pair. And then I see to get right under it, I have to stop at -4. So I'm going to go ahead and put my x is -4. And then to go straight to the ordered pair, straight to the point, I have to go up. And when I stop on the point, I see that my y is +5. And I know it's positive because I moved up. So that's my new ordered pair. Okay, let's try another one. And if you want to pause here and try them on your own before you check your answers, you can do that as well to make sure that you're actually understanding it. So the next building we're trying to locate is the dog park. And this says it's 2 units. I'm going to use a different color. Let's use purple. Okay, 2 units south from skate park. So skate park is my starting point. I'm going to go ahead and circle that. And I know I'm going to come over here. I'm going south. So I'm going to be going down in going underneath the 0. So let's go and start here. And it's only 2 units, so I'm going to do 2 bunny hops, and that is all. This graph looks a little bit confusing because there's another line going right here, so try not to get confused. And the only reason I know that is because of my ticks. Okay, so 1 bunny hop, 2 bunny hops. So my point would be right here. And when it comes to getting the ordered pair, start at 0, 0. To get to that point, I have to move to the left to -3 to get right on top of it. So my x is -3. And then I'm going to go down to the actual point, and then I realize that my y is -2. Okay, the movie theater. The new movie theater that they're building is 3 units east of the school. So locate your school first and determine which way is east. It looks like east is going to the right. So I'm going to do bunny hops to the right. I'm going to erase this so it doesn't confuse you all. But here's the school. Okay. All right, so here's my school. 3 units east of the school. So I'm going to move to the right. 1, 2, 3, and there is my new points. Now finding the new ordered pair, start at the origin. Start driving to the ordered pair. And you're not driving, you're just moving. But I like to think of it as direction. So I'm going to go to the right. Go right up underneath it. That means my x is 7. And then go up to your final destination, which is the point. And then go over to the x-axis to see, to the y-axis to see what that number is. And that there is a +2. Okay? Okay, when we're looking at this question, it says, what is the value of the x-coordinate that is 9 units to the left of 5, -8? Because they're only specifically asking us for the x-coordinate, if you think back, the x-coordinate is really just a horizontal number line, okay? So this is my x. If they were asking me for the ordered pair, you can draw the entire coordinate plane, but in this instance, they're just asking me for the x-coordinate, so I know the y is not going to change. So all I'm going to change is the x, and that's all I'm going to focus on. And so when I look at this, here's my 0, and currently my x, and I'm just focusing on my x, is on the +5. So 1, 2, 3, 4, 5. And it's telling us it's going to move 9 units to the left. So to the left is going to be in this direction here. And I'm going to go ahead and just bunny hop 9 units to the left and see where we end up on. But let me make sure I have enough ticks. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 units to the left would put me here. Now keep in mind, just because I moved 9 units to the left does not mean that my 5 is now 9. It is not 9. Now granted, my y is going to stay y because I didn't move on the y-axis. I just moved the x. So keep it as -8. And then my 5 is now, if we're going by ones, this is -1, -2, -3, and then -4. So my y is -4. Okay, so just keep in mind, if they're asking us to move just the x-coordinate or to get the, we're just moving on the x-axis, don't worry about the y-axis because we're just focused. That means the y will be the same. But if they're asking us, let's say, let's change this up. We can change this up and do something. Let's practice. So I'm going to put a question up. You're going to pause it and see if you understand. So let me erase this. Okay, so let's say the question was, what is the value of the y-coordinate that is 4 units to the left of 5 comma negative 8. So if that was the question, and I want you to pause and try this on your own, but if that was the question, now we go back to, they're just asking us to focus on the y coordinate. So the y coordinate is just the y. Here's my x. Here's my y. And that means nothing is going to occur to my x. So my x is going to remain 5. And I'm going to be, and I'm sorry, I should have changed this to, because it's the y coordinate, it can't move left or right. It can only move up or down. So let's change it up. Okay. So the question is, what is the value of the y coordinate that is 4 units up? I'm going to read it one more time just to make sure, because I know I'm scratching out a lot. What is the value of the y coordinate that is 4 units up? So the fact that they're telling me up lets me know that this is on the y-axis, or if we move further back, on a vertical number line. So I'm just going to create my vertical number line, because remember, up or down is a vertical number line. Left or right is your x-axis or a horizontal number line. All right, so this is my y-axis. So here's my 0. And I'm going to move 4 units up, but let's go ahead and graph my negative 8. So 1, 2, 3, 4, 5, 6, 7, 8. So negative 8 would be right here. And I'm going to bunny hop 4 units up. So 1, 2, 3, 4. And so my new point, or my new value for the y coordinate, would be right here. So let me just make sure I got my number. That is negative 1, negative 2, negative 3, negative 4. So negative 4 would be my y. As you can see, your x does not change, because for your x to change, they would have to tell you to move left or right. And we didn't move left or right. They only said the y coordinate. So keep that in mind. And I'm going to say that one more time. If they're referring to the x coordinate, and they're telling you to transform or to move your x coordinate around, your y will remain the same. Your x will change. But if they're telling you to move your y coordinate around, your y will change, and then your x will remain the same. Okay? Okay. Reflections. This is, let's go through this. When we look at ourselves in the mirror, we see our reflections. And when you look at yourself, it's a flipped version of you. And I kind of wanted to show you this picture so you can see how a reflection can be used on a coordinate plane. So a reflection is, when we look at this tree, if we were to think of a coordinate plane, and we see that there's a tree here, and then here's the water, and then it's been reflected into the water. So it looks like this is our halfway point right before it's been reflected. So if we look at this, this looks like the tree has been reflected over, we would call this our x-axis. So just keep that in mind when moving forward. A reflection is just a flip. It is a flip, and it's going to be flipping over a certain line. And so that's when we get into the coordinate plane. And I'm going to show you how to make that flip on the coordinate plane in a really simple way. All right, so our line of reflection is our mirror line. So in this case, on a coordinate plane, my line of reflection could be my x-axis, or it can be my y-axis. But that's really important, because you will get different coordinate pairs, different ordered pairs, depending on what your line of reflection is. And I'm going to show you that now, so please pay attention. When they're telling us to flip, let's start with D. Let's say they're telling you to reflect point D across the x-axis. They're always going to tell you what to reflect it across, or what your mirror line is. So in this case, if they say the x-axis, this is my line of reflection. That means I have to go over this line, okay? So your line of reflection is your center point, and then you have to go over it. So if they're telling us to reflect point D, All you have to do is count the distance from point D to your line of reflection, which is the x-axis. So in this case, 1 unit. That same 1 unit, you want to keep going in the same direction across your line of reflection. So you only went a distance of 1 unit, so now we're going to go 1 more unit down, and then here's my new point. Okay, so I just reflected D, and then so here is my, I'm going to call it D prime because down the road that's the name you're going to be using, but here's my D prime. It's just another word for that's my reflected image. Okay, so when we look at this, you know you did this correctly because a line of reflection will be the same distance from the original image to the new image, or the original point to the new point. Okay, so keep that in mind. There's 1 unit here and then a 1 unit here. Let's just try another one. So let's say they tell us to reflect point A across the x-axis again. Once again, that's really important, listening to what they're telling you to cross over or reflect over. So here's my x-axis, so I know if I'm reflecting across it, I got to get across that axis. So before I can do that, I have to find the distance to my mirror line. So in this case, is the x-axis. So the distance is 1, 2, 3. So right now I just made it to my mirror line, and now I need to reflect the image. In this case, the points. So if it was a distance of 3 units to my mirror, I gotta now do an additional 3 units to my new location. So 1, 2, 3. And so my new point would be, or my reflected point would be here. And I'm gonna call it A prime. This little sign here stands for the word prime, but that's neither here or there. You'll learn that down the road, but this is just your reflected A. Okay, so you know you did it correctly because there's 3 units down going to your mirror and then 3 units to my new point. Let's try another one. I want you to pause and then try this on your own. So I want you to reflect point C across the x-axis. So if you want to pause here, if you're in class, pause here, maybe have somebody go up to the board and see if they can do it on their own. Or if you're on your own, like your Duval homeroom, pause and then see if you can do it. All right, so it clearly says I want to reflect point C across the x-axis. So I got to get across it. I got to flip it across it. So let's find the distance first. So in this case, we have to move up to get to the x-axis because it's not underneath us, it's above us. So we're going to go 1, 2. So my distance to my mirror is 2 units, and that means now I have to do an additional 2 units to get to my new location, my reflected image. So 1, 2, and here is where my new point would be. Okay, so that's going across the x-axis, but a reflection can also be across the y-axis. So I want to show you how to do, I'm going to leave these on here just so you can see the difference, but if you're going across the y-axis, ask yourself, what do you have to go across? Literally, what do we have to jump across? And it's exactly what it sounds like. I have to go across the y-axis. So the y-axis is vertical, so I got to make myself go across it. So let's look at reflecting. Here's point B, and I want to reflect it across y-axis, or across the y-axis. So if I'm reflecting it across the y-axis, here's my mirror. I got to count the distance to my mirror. So here's point B. It is 1, 2, 3, 4 units to the mirror. So now I'm going to do 4 units away from the mirror. So 1, 2, 3, 4. And so here's where my new B would be. Granted, guys, every point's going to have a different distance to whatever the mirror line is. So it's not every time I'm going across the y-axis is going to be 5 units. Every time I'm going across the x-axis is going to be 2 units. It is whatever the distance is from your points to the mirror. And whatever that distance is to get there, you're going to use that same distance going away from your mirror to get the new point. So let's do another one. I I want to reflect, let's start here. I want to reflect point Z across the y-axis. So I know I'm going across the y-axis, so I got to jump this way to the left, because if I went to the right, there is no y-axis. So there's only one way to go. If you're ever asking yourself, what is the way to go? You're going to use what is given to you, and that's telling you to go across the y-axis. So distance to the y-axis, which is my mirror, is 1, 2 units. To get there, so to get to my new point, I got to get 2 units away from my mirror. So 1, 2, and then my new point would be right here. That would be my Z prime. Okay, I want to show you something really important. When you are reflecting points, please keep in mind it does make a difference if you're going across the y-axis or the x-axis. Because if you look at Z, when we did Z and we went across the y-axis, my new point was over here, right? But let's say they told me to reflect across the x-axis. I'm not going to the left. The x-axis is down here, so I have to go down. So the distance to the x-axis is 1, 2, 3, 4. So I got to go 4 more units. 1, 2, 3, 4. And so this is where my point would be if it was across the x-axis. Okay, so just keep that in mind. It is very important to read what they're telling you to reflect it across. Because as you can see, I'm sorry, this is Z. As you can see, you're going to end up somewhere different, and your answer will be wrong if you don't go across the correct line of reflection.